Hi, my name is Rachel Shearer. I'm a software engineer on the Google Accessibility Engineering team, and I'm here to talk about making your web apps accessible using HTML5 and ChromeVox. So I'm actually going to start this thing right off with a demo. I'm guessing that some of you have seen this page before. This is Sergey's Google+ profile page. There's a UI control in the upper right called the Add to Circles widget that you can use if you want to add Sergey to one of your Google+ circles. You just hover over it with your mouse, and you can see the drop-down menu open up underneath. You can interact with this menu by checking checkboxes. You can create a new circle at the bottom. And I'm guessing that most of you out there probably interact with the control the same way, hovering over it with your mouse. And so this is an interaction that looks really good, and it performs really well for you. But now I want you to try something for me. Imagine that you can't see the screen, and you can close your eyes if that helps. So you can't see the screen, and you want to add Sergey to your circles. But if you can't see the screen, then you can't use a mouse. So maybe you'll be using a keyboard instead. But how do you hover over the Add to Circles widget if you're just using a keyboard? The answer is you can't. It's impossible. So this is an example of a UI interaction that looks really good and performs really well, but it only performs really well for a certain kind of user. And that's the kind of user who can use a mouse. But as web developers, it's really important for us to take into account that there's lots of different kinds of users, and not all of them can use a mouse. And we really need to make sure that we're doing a good job for those users. And that's what accessibility is all about, making your web apps usable by everyone. It includes people who can't use the mouse, and it also includes people who use assistive technology. Assistive technology is basically software or hardware that makes it easier for someone with a disability to use the internet. So there are lots of different types of disabilities and special needs that users might have. But for the purposes of this tutorial, I'm going to focus on solutions for three groups of users: blind users, users with low vision, and motor impaired users. And the reason for that is that we know something very powerful about these users. We actually have a lot of information about how they're going to be accessing our apps. Blind users will generally use a screen reader that describes the page using speech or Braille output. And I actually have a picture of a Braille display right here. This is a close-up of a Braille display. And most blind users who use a screen reader, whether or not it has speech output or Braille output, will use standard keyboard for input. Low vision users will generally use large fonts or something called a screen magnifier. And I'll show you what a screen magnifier looks like on this tab. So this is an example of a screen magnifier. I'm selecting part of the page, and you can see that it's expanding it at the top, making it really big so that someone who has low vision will be able to see it. And so that's the second type of user. Motor impaired users who can't use a mouse might use some kind of special keyboard or even a voice control interface to interact with your app. So because we know a lot about the assistive technology these users are going to be using, we can do a lot to make sure that our web apps perform well for them. I also want to note that these three groups of users have something big in common, and I've actually already talked about it. These three groups of users can't use the mouse. So when you're testing your apps, it's really important to make sure that you test it with the keyboard and that you can use it without using a mouse. So now that we know a little bit about the different kinds of users who might be accessing our app, I want to talk a little bit more about testing. I already mentioned that we should be testing our apps using just the keyboard, but I want to introduce a tool that I'm going to be using during this talk. This is ChromeVox. ChromeVox is a screen reader for Chrome that my team at Google built. ChromeVox will help me demonstrate better how an assistive technology user might experience a web app. It's really easy to use because it's a Chrome extension, and it was designed completely for the web. You control it using keyboard shortcuts, and it speaks the contents of pages using the Chrome TTS API. There's a lot of other kinds of screen readers, but we feel that ChromeVox particularly shines as a testing tool. It interprets pages pretty much the same way that other screen readers do, but because it's a Chrome extension, it's really easy for developers to set up and use. So how does ChromeVox work? Well, it works the same way as any other screen reader. Let me demonstrate. It's actually been running in the background this entire time, but I'm going to turn it on now to let you hear what it sounds like.
Screen readers and magnifier.
So I'm going to walk through this slide using keyboard shortcuts to control ChromeVox so you can hear what it has to say. And it actually already started speaking this slide already.
Heading Group, Screen Reader Introduction. Heading 2. Screen readers and magnifiers allow the user to explore both static text and interactive elements.
All I'm doing is using the keyboard to drive ChromeVox around the page.
Here's an example web form to demonstrate. Enter your name, edit text. Choose your favorite color, red, list box 1 of 10. Submit button. Having trouble? Click here for help link.
So you saw that ChromeVox was not only speaking the static text, but it was also giving you sound indicators of what kind of UI element that you were interacting with at any given time. And that's basically how all screen readers work. So someone who can't see the screen is going to get the full experience of what's on the screen. So now that we know more about the different kinds of assistive technology and how we can test our apps using only the keyboard and a screen reader like ChromeVox, let's talk about how we get there, how we get to building a more accessible app. First, I'm going to talk about the building blocks, the essential things that you need to know when you're just starting out. And then I'm going to introduce an approach that we've been trying out here at Google, a systematic step-by-step approach to testing and building for accessibility. After that, I'm going to go a little deeper and talk a little bit more about custom interactive controls, some of the more complex interactions that you see, like the Add to Circles widget. And then at the end, I'm going to list some tools and resources that you can use to help you. So let's start from scratch at the DOM. We can look at the DOM of a page by opening it up in the developer tools, which I'm going to do right now. So this right here in the left-hand pane is the DOM. You can see all of the slide elements. Inside this slide, you can see the H group element and the article, and you can actually see the slide that I'm looking at right now, and this is the DOM structure: article tags, headings, and the hierarchy. So the interesting thing about the DOM is visually impaired users using assistive technology like a screen reader see only the DOM. It doesn't matter what your page looks like. They see only the building blocks of the page. And keyboard-only users navigate the page in DOM order. So they go basically top to bottom in the DOM, moving focus around to navigate the page. So you really have to adjust your thinking here. The DOM is the user's mental image of the page. They can't see what the page looks like, and they're only seeing the DOM. So the way that you build your app, the app skeleton, that's the way these users are going to interact with it. So knowing this, we can think of some best practices that will help these users. The first is that we want to create logical sections of the document to group interface elements that are related together. And you can use HTML5 semantic elements like nav and header to make this easier. Nav to group all your navigation elements together, and header to group all your header content, and there's other HTML5 semantic elements too. Even some old school ones like H1, H2, and H3 will help users better understand the structure of your app. You also want to make sure that parts of controls are grouped together in the DOM. So I see this a lot, where you'll have a drop-down menu button somewhere in the DOM, but the drop-down menu itself is all the way at the end of the DOM. And you can use CSS to make this make sense visually, but if someone sees only the DOM, they're not going to know where that menu is, because it's all the way at the end of the DOM. So you can make things easier by grouping things that are supposed to be together in the DOM. And then this last point is pretty basic, but I'm going to say it again. You really want to make sure that you're using CSS for layout instead of using tables. For these users, tables mean structured data. They can't see what the page looks like, so using tables to lay out your page is going to be very confusing for these users. So this slide is an example of the things I was talking about. This is a quote that looks like it makes a certain amount of sense visually. The rain in Spain stays mainly in the plain. So let's see how ChromeVox reads it. And remember that ChromeVox, because it's a screen reader, is reading only the DOM. So let's see what ChromeVox does as I move it through the page.
Here's a quote article. The plain in rain stays mainly in the Spain.
So that didn't make a whole lot of sense. And even though this sentence makes total sense visually, ChromeVox was jumping all over the place. And that's because if I open up the developer inspector and inspect these elements, you'll see that the DOM for the page actually looks like this. The DOM underneath the page has these words all over the place. Plain in rain stays mainly in the Spain. And we've used CSS to position it in a way that looks like it makes sense. But ChromeVox is reading the DOM. The layout of these words in the DOM is exactly what ChromeVox is going to read. It doesn't know what the page looks like visually. It's only reading the DOM. So it's really important to make sure that your DOM makes sense when you're building a web app. The next thing I want to talk about is interactive controls. And this, I swear, is one of the easiest things you can do to improve the accessibility of your site. Instead of using generic divs and spans for buttons and links and stuff like that, use the native HTML tag that's most appropriate. I use the terms div soup and span salad to describe apps that are built like this. Don't use div soup, don't use span salad. It just creates a really confusing DOM and it confuses these users. And there's two reasons why. First, screen readers can't identify generic divs or spans as controls. They just see a div or a span in the DOM, and they don't know what that's supposed to be. They don't know that your span with an onClick handler is supposed to be a link. They can't crawl through the JavaScript to try and figure out exactly what the developer meant. So they're just not going to speak it as interactive at all. And a user can completely skip over things that you want them to interact with because you've identified them only as spans and divs. Also, spans and divs aren't focusable by default. They won't receive keyboard events. And this is even worse. A user who can see the screen and who is trying to interact with something that you styled as a button, if that's not focusable, they're never going to be able to send keyboard events to it. So, no div soup and no span salad. Use native HTML tags wherever you can. I also want to note that there's no reason not to use them for modern browsers. You can style them however you want, and you can make them look like anything. And they give you focus management and keyboard support for free. Screen readers know exactly how to identify them, and users know how to use them. And that's really one of the most important parts. So this slide is a quick example of how this works. On this slide, there's a button, and you can see that I created it using a div and an onClick handler. So let's see what ChromeVox says. I'm going to turn ChromeVox on again.
Spain, heading, group, custom button, live coding example, heading 2.
So I'm just going to move ChromeVox through this slide, and we'll see what it does.
Click on this button, article, send, clickable.
So you'll see it said the word send, and it said clickable. But there's no indication that it's a button. ChromeVox knows to say clickable. It's smart enough to say clickable when it encounters something that has an onClick handler, to let the user know that this button is somehow interactive. But as a keyboard-only user, if I try to press enter in order to interact with this button, I'm pressing enter like crazy now, nothing happens. That keyboard event isn't getting sent to that button, and nothing is happening on the page. But the good thing is, the fix for this is really easy. You want to change this div into a button. It's just one simple change, and I'll make it right now. I'm going to turn ChromeVox off first.
ChromeVox is now inactive.
So I'm just going to change this div tag into a button. And you'll see that nothing visually on the page changed. The CSS is doing everything right. So now let's try this out with ChromeVox again.
Refresh button.
OK, let's move on to the send button and see what happens.
Send button.
Right, this is great. ChromeVox said send button, and it used an audio indicator to indicate that this is a button. And if I press enter, the alert opens, just like the onClick handler is supposed to do in the code.
Send button.
So this was a really simple change, and this is something that is really simple to do, but it can really save you a lot of time later on, so you don't have to re-implement all of this stuff later on your div soup and span salad. The next thing I want to talk about is labeling. Labeling is also something that is really important, now that we're talking about controls. You want to make sure that you're labeling your form elements, and the label element is really perfect for this task. Another thing that you want to make sure you're doing is labeling your images with the alt attribute. And this is really important too. All images need to have the alt attribute. Not just some of them, all of your images. And the reason why is that if there is no alt attribute on an image, a screen reader is just going to try and speak that image anyway. It's going to try and identify that image to the user. But it's just going to speak the file name of the image. And for really complex web apps, that can get horrible. The file names for some of the images that I see every day are really, really long strings of characters. And that gives users a really terrible experience. And I just want to say, if the experience is that bad, these users will just leave. A page full of unlabeled form fields and unlabeled images is a terrible experience for users. And so there's two kinds of alt text that you need to have. Every image needs to have it, but important images need to have descriptive alt text. This is alt text that actually describes what the image is. For images that are decorative, you can give them blank alt text. So this is alt text that tells the screen reader that it can skip this image entirely. Blank alt text tells the screen reader not to try to read the file name, just skip the image entirely. It's not necessary. And so you can see on this slide, I've got an image that's ostensibly a bullet point, and I've given it blank alt text. We don't need a screen reader going through a page, reading all of the bullet points, It's just not necessary. So this next slide is another live example. This is a form that looks like a lot of forms that I see every day. You've got these labels underneath these text fields, username and PIN, and they're positioned visually underneath the form. But you can see in the code underneath that they're not actually explicitly associated with the form in the DOM. And we also have an image, just for fun, that's unlabeled. So let's see what ChromeVox does with this page.
Password edit text. Edit text.
So you'll see it's saying edit text and password edit text. It's saying password edit text because we gave that input field the type password. So that's a little bit better than just saying blank edit text. But for both of these fields, there's actually no indication what the user is supposed to put in there. There's no label. A user would have no idea what they're supposed to do. Let's try out the image.
Password edit text. 901T3 and 94T3 image.
So this is an example of what I was talking about. It can't figure out what that image is supposed to be, so it just reads the file name. And it's totally inexplicable what this image is supposed to be if you can't see the screen. So you can clearly see that navigating around a page that is full of unlabeled fields and images will get really tedious for a user. And again, this is another really easy fix. If you change these spans that have username and PIN, if you change these into labels using the label tag, you can fix this problem really easily. So let's do that right now.
ChromeVox is now inactive.
I'm changing this span to be a label tag. And I'm changing the second span to be a label. And I'm going to actually explicitly associate it with the username field in the DOM. So and the second one is going to explicitly be associated with the password field. And you'll see, again, visually that nothing changed. CSS is still styling things correctly. And then I'm also going to give this poor image an alt tag, golden gate photo. All right, so I've made these changes. Let's try it again with ChromeVox and see what happens.
Article, username, edit text.
So you see it's actually saying username edit text, whereas before it was just saying edit text.
PIN, password edit text.
And this is really great. It's also saying PIN edit text instead of password. You can see how that distinction on this page might be really important. So it's important to make sure this password field is labeled correctly. Let's see how that image sounds.
Golden gate photo.
So you can see right away, making these simple changes enabled ChromeVox to interpret this page correctly to the user. The user gets better information about what these form fields are supposed to be. And it's low-hanging fruit like this that is really easy to fix. The thing is, it's easier to build this stuff in from the beginning, other than having to go back later and find all of your form fields that aren't labeled and all of your images that are missing alt tags. So this next topic is about managing focus. And we're going to get a little bit more advanced here. Basically, you want to make sure that you're managing focus. And the reason for this is simple. Users who are not using the mouse, keyboard-only users, are navigating your page by moving focus through the DOM. You can think of focus as like their cursor. So you can really help these users out by making sure that you know where focus is and by managing it appropriately. I'm going to give you a quick demo of what someone navigating through a page using focus looks like. I'm going to use the google.com/accessibility site. I'm just going to press tab. And you can see that this little blue box is moving around the page as I press tab. Pressing tab in a browser moves focus throughout the page. It's just moving it linearly down the DOM, and you can see it move throughout this page. So someone that is navigating without using a mouse, someone who is navigating using the keyboard, can press tab to move linearly up and down the DOM, or shift tab to move back up. So why is this important? Well, you can place focus by using element.focus. And if you pay attention to what the user is doing, you can really make things easier for them by putting focus into appropriate places as the user is performing a task. And when the user is done with a certain task, you can return focus to where it was before. And if you do these things, you're really going to help them out. A lot of times I see apps where focus might just be dropped on the floor. And that actually means that focus is being reset back to the top of the page. And that can be really frustrating. If you're in the middle of editing something and the focus is dropped on the floor and you're sent all the way back to the top of the DOM, that's frustrating. And it's something that is really common for users to experience. I'm just going to quickly show you what that is like. And again, this is something that I see all the time. It's a pop-up dialog button. And you can see that if you click on it, it opens the dialog. And you can press OK and the dialog disappears. And if you look at the code below, you might be able to notice that there's a red flag here. The dialog in the DOM, this thing, is actually before the button. And you can remember from earlier that I said that you want to make sure that things in your DOM are grouped logically. So the fact that this dialog is before the button, that doesn't look super good. But let's see what ChromeVox does. Turning ChromeVox on.
Heading group, pop-up dialog, live coding example, heading 2.
So we're on the heading. Let's tab to the button.
Heading group, article, buy more printer ink button.
I'm going to press enter, and hopefully the dialog will open. Great, the dialog opened, but the weird thing is that the little orange outline, the purple and orange outline, shows you where focus is. And focus didn't move. Focus is still on the button. This dialog is open, but ChromeVox didn't speak anything, and focus is still on the button. So a user who can't see the screen has no idea that something happened. They have no idea that the dialog even opened. And that's a really bad experience. And if the user did somehow try and get into the dialog, like maybe they're a keyboard-only user who can see the screen, they'll have to tab all the way around the page before they can get back to that dialog. And that's something that users might not be able to figure out. You'll notice that if I open the dialog and somehow, get inside of it, and I close the dialog, focus just gets dropped on the floor. The previously focused element, you can see that little orange square, that's gone. It's not in the DOM anymore. And nothing happened. ChromeVox didn't speak anything. And I don't know where I am on the page, and you actually have to tab backwards
Exit dialog
to get back to the button. So that's a poor experience as well. But the fix for this, again, is actually pretty easy. You might be noticing a pattern here that all these fixes are actually pretty easy. And the good thing is there's a number of different ways you can improve this experience. One of the ways is actually putting focus on the button as soon as the dialog opens. So you can see here in the code, I'm inside this method, confirm, and this is when the dialog opens. So I'm just going to set focus on the OK button in the dialog as part of the dialog opening using .focus. Then I'm also going to be a nice person, and I'm going to set focus back on the button when the dialog closes. So I'm going to, this button is called confirm. I'm going to set focus back on that button there. Just double checking, confirm. Okay, good. So now that I've added .focus to the confirm and close dialog methods, let's see if we've improved this experience at all for our users. I'm going to turn ChromeVox back on.
Article, refresh, button.
Move back up to the button.
Buy more printer ink, button.
And open the dialog.
Entering dialog.
So you'll see right away that this is much better. ChromeVox announced that we entered the dialog, and focus is thrown right back onto the OK button. And even better, a user who can see the screen and is maybe only using the keyboard starts right off in that dialog, and they can interact with it right away. A ChromeVox user or any screen reader user would be able to navigate around the dialog and figure out what they're supposed to be doing. So let's try closing the dialog. I'm going to hit enter on the OK button.
Exit dialog.
And you'll see that ChromeVox said exiting dialog, and focus is thrown right back onto the buy more printer ink button. So the user is right back where they started, and you've helped them out a lot when they're going through this dialog workflow. So the last thing I want to talk about while I'm talking about building blocks is keyboard shortcuts. And keyboard shortcuts can be really helpful to help users navigate through your app efficiently. And they're also really good for power users who maybe aren't using assistive technology and who maybe can see the screen. But for power users who use your app a lot, keyboard shortcuts can be really great. There's two different kinds. Navigation shortcuts jump between major interactive areas. You can think of these like the J and K shortcuts in Google+ that move between posts in the stream, and I'll show those off to you right now. I'm on the Google+ page. I'm going to go into my stream. You can see that I can use J and K keyboard shortcuts to move between posts. These are navigation shortcuts. They're great because they help break your UI into different units. They prevent users from having to do a bunch of tabbing in order to get to the next post in their Google+ stream. The second type of keyboard shortcut is an action shortcut. Action shortcuts basically just simplify a user's workflow. So in Google+, the equivalent of this would be pressing R to reply to a post. So you'll see you just press that one keyboard shortcut, I just pressed R, and it opens up a new reply field, and you can start composing right away. instead of having to find the reply button and press it and open it back up. It's really simple, and it enables a complex action. The important thing to remember about shortcuts, though, is that they really need to be documented somewhere. And even if they are documented, not all users are going to know about them. So keyboard shortcuts are great, but they're not a band-aid for an inaccessible page. You might have all the keyboard shortcuts in the world, but if you don't label your form fields and you don't have alt attributes, a user is still going to have a bad experience. So keyboard shortcuts are great, but they don't solve all problems. So now that I've given you the building blocks, let's move on and talk about a systematic approach to building accessible web apps. First, you want to take care of the most basic errors. You want to clean up the low-hanging fruit. Look at your DOM order and make sure that related controls are grouped together. You can create logical groups with semantic tags like nav, header, h1, and the landmark ARIA roles. I'll be talking about ARIA in a couple of slides, so hold on for that. The next thing you want to do is use native HTML controls wherever possible, and try to avoid div soup and span salad. Finally, you want to label your controls and images. And the great thing about these basic errors is that they're easier to catch and fix early in the process. But once you catch them, the fixes are really easy. Next, you want to think about keyboard navigation. Try your app out with just the keyboard, and make sure that you can reach all interactive controls by tabbing. Make sure you can use Enter and Space to interact with UI controls, and manage focus to make sure that users can perform tasks with the keyboard efficiently. Keyboard navigation is so important to take care of early in the development process. When you get keyboard navigation working, you ensure that screen reader users will be able to navigate through your UI controls individually. You also ensure that screen reader users will be able to activate those controls. By taking care of DOM structure and keyboard navigation, you'll have done 90% of the work that you have to do. So now that we've discussed the building blocks of accessible web applications, let's talk about the other 10%. In this part of the talk, I'm going to give more detailed information about custom interactive controls. And I'm going to use the Add to Circles widget from Google+ as an example throughout this section. So, native tags are really great. Native links and buttons are awesome. But if you want to enable complex interactions like the Add to Circles widget, in many cases you're going to end up with div soup. But it's not the end of the world. What you need to do is re-implement the semantics of a native control on the custom control. And I actually already talked to you about how to do this. You want to think about focus management for your custom control, and it's also important to think about keyboard support. Re-implementing both of those things is going to give your users a really good experience. You also need to do additional work for screen readers, and that's adding something called ARIA attributes. I said before that it's impossible for screen readers to identify what a bunch of divs in the DOM are supposed to be. So adding ARIA attributes gives screen readers a hint as to what your custom controls are supposed to be so they can do a better job interpreting them to the user. So it helps you work around the downsides of div soup for screen readers. So coming back to the Add to Circles widget, it's pretty much the definition of div soup. And this is the simplified version of the Add to Circles widget. The actual code for it would not even fit on this page, and it's mostly divs and spans. The Add to Circles widget, implemented just like you see here, is impossible for a screen reader to understand, and it would be really difficult for a keyboard-only user to use it. So I'm actually going to walk you through how we improved it. It's still div soup, but we've got extra information in there to make it a lot easier for keyboard-only users and screen reader users to use. I'll walk you through the code because I'll be talking about this later. The first div that you see here is the Add to Circles widget itself. And the second div is the dropdown. You can see it's got a bunch of divs for checkboxes. And it's actually appended at the end of the DOM for CSS reasons. So that's one of the things that we needed to fix. So the first thing we have to do is manage focus. Remember when I said that divs and spans aren't keyboard focusable? Well, you can make them keyboard focusable by adding an attribute called tab index. There's a bunch of different ways to add tab index, and they're listed on this slide. But essentially, if you add tab index equals 0 to a div, it adds that div into the tab order. So if you have a user who is navigating around the page by pressing tab, that user will be able to focus on that div and send it keyboard events. So tab index is really important. You can add keyboard handling, and you can add labels, and all that stuff I talked about earlier, but if your divs aren't focusable, a user won't be able to interact with them. And so that's why it's so important. After that, you want to make sure that you're placing focus wherever necessary with element.focus. Remember, we can proactively place focus that way to create an efficient workflow for users. So with custom controls, you also want to make sure that you show the keyboard some love. You want to add key handlers so that a user can use enter and space and arrows and escape to interact with your control. And one of the best ways I've found to do this is to pick a native control and then try and mimic it. This can be a native control as simple as a button or a select box, or it can be something as complicated as something that you'd find on a native operating system, like a tab panel or something like that. But these kinds of native controls usually handle keys like enter or the arrow keys really well. And users know how to interact with these kinds of widgets. They know to press the arrow keys to move up and down in a select box. So if you mimic that native control, a user is automatically going to know a lot about what they have to do in order to interact with your control. And the W3C actually has a really good guide to common keyboard patterns that you see. I'm going to open it up here so you can actually see what this looks like. If it goes here, under the Design Patterns section. So if you look at this guide, you can actually get a good idea for what users might expect when they encounter your control. So this code is just an example of what a keyboard handler might look like underneath here, with return on reply key down and checking for key codes and stuff like that. So back to the Add to Circles widget. What you're going to be doing is picking native elements and then trying to mimic them, just like I said before. The Add to Circles widget, to a keyboard-only user or a screen reader user, is probably most like a button. To a sighted user, you hover over it, but then again, a keyboard-only user can't hover. So let's make it like a button. And so making it like a button, the first thing we're going to do is add tab index equals 0 to make it keyboard focusable. That's probably always the first thing you're going to do on a custom UI control. And then after we do that, we're going to add keyboard events like enter and space. We're going to listen for those so that we can activate the button and show the dropdown. Remember, a keyboard-only user can't do hover. So enter and space mimic the behavior of a regular button, and a user is going to expect to be able to do that. As for the menu itself, it's a drop-down menu, and it's actually kind of like a modal dialog. If you think about it, when you hover over the button, and I'll show you what that looks like again. So if you go back to the Google Plus Add to Circles button, if you hover over it, you have this modal dialog that appears. And you can interact with it, you can check buttons, you can do whatever. But once you move the mouse away from it, that drop-down disappears. And that's pretty much the same way a modal dialog works. You can't interact with the rest of the page until a modal dialog disappears. So we decided that we should implement dialog behavior for this drop-down menu. And the way dialogs work, as we saw in that earlier example, is that you want to set focus on the first focusable element, like we did on the OK button in the dialog example. So that's what we want to do for the drop-down menu. We ask for the first focusable element, and we put focus on it. The next thing that you want to do is trap focus inside the dialog. You don't want the person to accidentally fall out and not know where they are on the page. We also added escape as a keyboard shortcut, because that's something that's commonly found in native dialogs. Then, another important thing to remember. When the dialog closes, we wanted to set focus back onto the Add to Circles widget, instead of dropping it on the floor. So I'll show you an example of how this works. I'm just going to use the keyboard instead of ChromeVox. So let's go back to Sundar's profile, and I'm going to get keyboard focus on the button, the Add to Circles button, and I'm going to press Enter. And you can see right away the dialog opened. There's a little blue outline around that checkbox that shows that we have focus on that first checkbox, and I can use Tab to kind of move through the rest of this dialog. So if I decided that I'm done and I'm going to be following Sundar, I press Escape, and you can see page focus goes right back to that button, which is great. That's exactly what we want to see from this Add to Circles button. So next, I want to talk about screen reader accessibility and the Add to Circles widget. And I mentioned ARIA before. So our Add to Circles widget is a pile of divs. And as I pointed out earlier, screen readers have real difficulty identifying what a pile of divs is supposed to be. So ARIA is essentially a set of HTML5 attributes that actually provide that information to screen readers. the information that a sighted user gets visually, you can provide to a screen reader user by noting with ARIA, this div is a button, or this div is a menu. It's important to note that you have to do everything else that I talked about earlier in addition to ARIA. Just adding an ARIA attribute doesn't actually give a widget keyboard handling or focus management or anything like that. You still need to add that stuff. ARIA is just a layer on top that specifically helps screen readers identify what things are. So let's talk about ARIA roles. There are two categories of ARIA attributes, ARIA roles and ARIA states and properties. The role attribute is static. It indicates that this generic tag is behaving a certain way. So in this example, this div here is going to be behaving like a button. It's taking on the role of a button. So the ARIA attribute on this div is role equals button. You can also use ARIA attributes to indicate composite controls. So those complex interactive controls I mentioned before that don't really have a native HTML equivalent, you can use ARIA there too. We can explicitly state that this next div is playing the role of menu item using the role equals menu item attribute. And there's a lot of different roles that you can pick and choose from to add to your generic controls. Another type of role that I mentioned earlier is a landmark role. And that's a role that can be used to organize the DOM in the same way that I mentioned before. You can use a landmark role to actually identify separate areas of your app to a screen reader. You can use them together with the new HTML5 semantic tags to create a really rich user experience. So in this example, I used the section semantic tag, but also gave it the role of search. This indicates to a screen reader that this section of the site is the search section. A second category of ARIA attribute contains ARIA states and properties. These are both dynamic. ARIA states add dynamic information about the current state of an element. And you can use them in addition to roles to identify what an element is currently doing. For example, this div is acting like a checkbox, so it has role equals checkbox. It also has the ARIA attribute ARIA checked equals true. And as this checkbox gets checked and unchecked, we can actually update this ARIA state in our JavaScript. And this tells a screen reader to tell the user, this div, it's actually a checkbox, and it's currently checked. There's a bunch of different states associated with the different roles that you can use to add richer information about the current state of a dynamic control. One type of ARIA property is the ARIA live property. And this gets a little bit more complicated, so I'm not going to go into a ton of detail right now. But essentially, you can use it to identify dynamic content on a page. So if you add the ARIA live attribute, you're adding it to elements that are going to get updated. And you can use the attribute to describe the types of updates that this element is going to be receiving. And if you want more information, here's a link to the W3C Guide to Live Regions, which I'll open up. So you can see there's a whole section here in this document on live region properties and how to use them. And this document can be really valuable if you're trying to learn about how to do this. ARIA live regions are something that can be really useful if you have a very complex page that is receiving updates all at once that might not be in the same area where the user has focus. If you remember that keyboard focus is like a cursor, and if you have a lot of stuff that is happening outside of where that cursor is, things get confusing really fast. So the ARIA live property is super useful and can really help you out there. So let's go back to the Add to Circles widget. Now we know about ARIA, and we have this pile of divs. So we want to make sure that we add some ARIA to ensure that a screen reader user can understand what the Add to Circles widget is supposed to be doing. So the first thing that we're going to specify is that this element is a button. So we're going to add role equals button to it, to this widget. And you'll notice that we have tab index equals 0 in there, which is really, really important for ARIA. Again, adding a tab index attribute to your divs or spans, to your generic elements, really should be the first thing that you do. We also want to specify that the Add to Circles dropdown dialog is, in fact, a dialog, like we decided earlier. So we're going to add role equals a dialog. And we did, unfortunately, also use divs for checkboxes here, so we also want to specify that those divs are indeed checkboxes. So we give them role equals checkbox and update ARIA checked in the JavaScript as the person checks or unchecks the checkbox. So now that we've added all of this ARIA for screen reader users, let's try out the Add to Circles widget with ChromeVox. So here we are on Sundar's profile, and we can see the Add to Circles widget right at the top. Let's try and interact with that Add to Circles widget using ChromeVox to see if we can add Sundar to our circles. So I'm going to use ChromeVox to navigate to the Add to Circles widget.
Navigation, Add to Circles button.
So that's great. You can see that ChromeVox said Add to Circles button. There's no indication that this is actually, some kind of strange widget that has a hover target and you need to hover over it. A user who can't see the screen doesn't care about any of that. We say that it's a button, and they know how to interact with the button. So let's press enter and see what happens.
Entering dialog.
So this is great. You can see that focus moved to that checkbox, and ChromeVox said entering dialog. You can move around with this checkbox, with tab to the other checkboxes, and let's see what ChromeVox says.
0 family, checkbox not checked. 0 acquaintances, checkbox not checked. 5 following, checkbox not checked.
So this is great. You can use tab to move around this drop-down dialog, and ChromeVox is speaking it just like you'd expect. Let's press spacebar.
Checked. 6 following, checkbox checked.
And you can see that ChromeVox updates as the checkbox is checked. It's actually listening for those ARIA changes, and it's letting you know that this checkbox is checked. Let's press escape to close the dialog.
Exit and dialog.
So this is awesome. The dialog went away, and ChromeVox announced that you're exiting the dialog. There's no indication that this is a drop-down and not really technically a dialog, and you might have had to hover over it. Someone who can't see a screen, this interaction is perfect. It's composed of UI elements that they know how to interact with, buttons and dialogues. Because people have interacted with this stuff before, they know how to do it. So it makes things a lot easier for these users. The Add to Circles widget seems really complicated. You've got to hover, it's not a standard UI control. But you can see with the combination of managing focus, keeping track of keyboard, and adding ARIA, we can turn it into something that makes a lot of sense for different kinds of users. Let's go over how we got here. First, you want to make sure that you're structuring your DOM in a sensible way. It's true for all web apps, and it's also true for custom controls themselves. You also want to make sure that you're using native HTML tags wherever possible to save yourself extra work later. You also want to make sure your controls and images are labeled. You want to make sure you have intuitive focus management, that you're guiding the user around the page by moving focus proactively. You also want to make sure that your app can be used entirely with the keyboard, because remember, not all users are able to use the mouse. You have to have keyboard handling and focus management so you can unplug your mouse, use your app, and have everything work just like you expect it to. And additionally, include ARIA for screen reader users to help screen reader users in the midst of div soup and span salad. So now I'm going to list some tools and resources that can help you get your app to being a more accessible experience. The first one is ChromeVox, which I was using to demonstrate. It's actually built in on Chrome OS, and it's available as an extension for Chrome on other platforms. It's something that any developer can install on Chrome and use right away. And the great thing about ChromeVox is that it's also open source. So you can access the source code at this googleaccesschrome.code.google.com link on the slide. There's other no-cost screen readers out there. VoiceOver and NVDA are examples of them. As a developer, it's super important to test your app using just the keyboard, but it's also good to take a test drive with the screen reader. Some other libraries with accessibility support include Dojo Toolkit, Gwt, and jQuery UI. So if you're trying to build your web app using components that already exist, these libraries are good to look at because they can take care of a lot of this accessibility stuff for you. So whether you're building a web app from scratch or you're working on refining a complex UI control like the Add to Circles widget, it's definitely possible to deliver a dynamic, accessible experience that looks really good to sighted users, but performs really well for all kinds of users. The first step in this process is really easy. Just close your eyes or unplug your mouse and try to use your app. Once you try that, you can probably figure out some things to fix that can make the experience a lot better. And finally, following HTML5 standards, especially ARIA, are going to get you the rest of the way there, to an app that works well for everybody. So thank you very much for tuning in to this developer tutorial. I hope you had a lot of fun watching it, or at least learned something. You can talk to me on Google+ using this goo.gl short link that's on this slide. And on Twitter, my handle is Rachel Shee. So I look forward to hearing from you, and that's it.